Good day, everyone. Welcome back again. Uh, Today we'll be looking at physics and we will be doing the projectile motion. Most of you requested me to explain what projectile motion is, and most of you said that you find this chapter very hard. This doesn't have to be very hard, and I will explain what projectile motion is all about. And yeah, by the end of maybe this lesson, you'll have a clear idea of what vertical projectile motion is all about. So first of all, we'll start by defining what a projectile is. A projectile is an object that has been given an initial velocity and experiences free fall. And your teacher might want you to explain it in his or her way, so please do that. This is how I explain what a projectile is, but if you have another definition, you can stick to that definition there. And yeah, let's say this is a building, and these are the windows, and here is you, and yeah, you're throwing something of a building. What will happen to this here? It will go up and reach a maximum height and then experience its free fall and fall back to the ground. This is what will happen. And on free fall, free fall is the motion of an object under the influence of gravity only. So let's say we are on the same building, and these are the windows. This is you, and instead of throwing the ball upwards, you just drop it. What will happen to this ball here? Of course, it will go straight downwards and then land on the ground here. Notice the difference between the two. The first one, we gave it an initial velocity. It went up and then down. The second one here, we didn't give it an initial velocity. It went straight downwards. So you can see the difference between a projectile and free fall. They are not the same, but they have the same idea. Yeah, this is what I wanted to say about the projectile and free fall. Let's look at the formulas that we will use. Yeah. And yeah, these are the four formulas that we will be using when dealing with projectile motion. You have to know them by head. And yeah, I know that sometimes they give you the formula sheet, but these formulas here are not that hard to memorize. There are only four of them. These are the formulas that you will use, and we know that G is constant, it's always 9.8 meters per second downwards, always vertically downwards, doesn't act upwards. So let's talk more about this G here. What is my paper? Okay. Sorry about this here. And yeah, let's talk about this gravitational acceleration. It can act as an accelerator for objects falling to the ground. If an object falls to the ground, this G here can increase its speed. When you say something accelerates, it means that we increase the speed or the velocity. And it can act as a decelerator for object moving away from the ground. If the object is moving away from the ground, gravitational acceleration acts as a decelerator. That means it decreases speed. Sorry about that. Let me. Okay, good. Yeah, it decreases speed. When the object is moving away from the ground, it decreases its speed. When the objects move towards the ground, it increases its speed. And yeah, it always acts vertically downwards. I already said this here, it acts vertically downwards always. So yeah, it is always 9.8. It is constant, does not change. And yeah, 9.8 meters per second squared. And yeah, we are done with gravitational acceleration. Let's move on to another one. And sorry about that. And yeah, I want us to talk about this here. Let's say you throw a ball upwards. What will happen to the speed of the ball when it is going upwards? Of course, the speed will decrease. Why does it decrease? Because when the object is moving away from the ground, gravitational acceleration acts as a decelerator. That means it decreases the speed. Here it was 19.6 meters per second. Here it's 9.8 meters per second. When it reaches its maximum height, it becomes 0 meters per second because it can no longer go up. So when it comes back to the ground, the speed starts increasing, but in the other direction. Here it's 9.8 meters per second, and then here it's 19.6 meters per second. Why does it increase? Because we said that when the object is falling towards the ground, the gravitational acceleration acts as an accelerator. That means it increases the speed. And we can see here that the speed the ball left with is the same speed that the ball will return with, but in the opposite direction. It left with 19.6 meters per second. It came back with 19.6 meters per second, but in the other direction. And then one thing we must mention is that the time the ball takes to reach its maximum height is the time the ball will take to return to where it was thrown. If it took maybe 3 seconds to go from here to here, that means it will take another 3 seconds to go from here to here. So the total time the ball is in the air is 3 seconds plus 3 seconds, which is 6 seconds. I'm just assuming that value there. I didn't calculate it. And yeah, this is what you have to know. When the object is moving away from the ground, gravitational acceleration acts as a decelerator. That means it decreases the speed. When the object is falling towards the ground, gravitational acceleration acts as an accelerator, which means it increases the speed. With that being said, let's do just one example to illustrate what I'm saying. Yeah, we will need this here. Let me put it here. And yeah, they say a stone is thrown vertically upwards with a velocity of 20 meters per second from the ground. So this is what will happen. This stone will move from here, reach its maximum height, and then return to where it was thrown. And where's my marker? Okay. Yeah. The first question says, determine how high above the ground the ball will reach. So we want this height here. We want the height from here. So we want this height here, h here. So how do we find the height here? Well, we know that the velocity when the stone is at its maximum is 0. So Vf is equals to 0 meters per second. And we're given the initial velocity here. And we know the g. So let's look at the formula that we can use. Can we use the first formula? Nope. We are asked to calculate the height, so the first formula does not have height. Can we use the second formula? Here, so we can use the second formula because we have final velocity, which is 0. We have initial velocity, which is 20 meters per second. We have g, and then all we have to do is to solve for change in y. And can we use the third formula? No, we cannot use it because we don't have time. Can we use the fourth one? Of course we can't, because we don't have time there. We are not given time. So let's go ahead and solve this one here. So what will we do? We will use the second formula, which says that is equals to VS squared plus change in y, and then let's substitute. The final velocity is 0, the initial velocity is 20, but we square it, plus 2. Let's talk about g. When the ball is moving away from the ground, g acts as a decelerator, which means we'll plug it as negative because it decreases the speed. So it's negative here. Negative 9.8 change in y. So 20 squared, let me see, what is 20 squared? 20 squared, it's 400. So 400, positive 400 to the other side, it becomes negative 400 is equals to negative 2 times negative 9.6, 9.8, it becomes negative 19.6. So we divide both sides by negative 19.6, we get 400 divided by 19.6, we get a value of 20.41. This is the value I get here, 20.41. Change in y is equals to 20.41, rounded off to 2 decimal places. And this is how they mark your answer. You get 1 mark for the formula, you get another mark for substituting, you get another mark for the answer. This is how you get your 3 marks. And then another question: determine how long the stone is in the air before falling to the ground. So if we know the time it takes for the stone to go from here to here, then we can determine the time the stone goes from here to here. So let's determine the time the stone takes to go from here to the maximum height. So we can use the first formula there, which says number 2. So sorry about that, I thought I was recording, and okay, let's continue. I think I was here. So we use the first equation, and then we plug in the values that we know. The initial velocity is 20, the final at its maximum height is 0, and when the ball is going up, the gravitational acceleration acts as a decelerator. So that's why we got this value here. And then when you solve for it, you get that change in t is equals to 2.04 seconds. So it takes 2.04 seconds to go from here to here, and it will also take 2.04 seconds to go from here to here. So the total time is 2.04 seconds. 2.04 seconds. So you can find this 2.04 seconds by doing this. Let me show you. Here is equals to V initial plus G change in T. I hope you can see there. So what is the final velocity? Of course, it will be minus 20. Is the velocity here. It will be minus 20. So that will be the final velocity is equals to initial velocity, which is here. It will be 0. And then when the ball is going up, when the ball is going down, this here acts as a accelerator. That means it increases the speed. So this will be 9.8 times change in t. Let me write it here. So the change in t is equals to 2.04 seconds. And yeah, that's how you can get this here. Or you can just use the theory that if here is 2.04 seconds, then here is 2.04 seconds. Then you do your calculations here, you get your 4 marks, and yeah, that's it.